Good morning students. Today we are going to discuss about module number 1, that is basic concepts. Here we are going to discuss about problems on supernode analysis. So let us discuss about supernode analysis because we are applying supernode when any one voltage source which is located between the boundaries of two unknown nodes. Let us consider the two unknown nodes like node A and node B. With respect to node A and node B, there is a voltage like node A as VA and node B as VB. And there is a source voltage Vs between the two unknown node voltages like VA and VB. So whenever there is a case like this, that means whenever there is a unknown source voltage or unknown voltage between the two unknown nodes like here VA and VB, then immediately we have to apply supernode analysis. So here the supernode analysis equation can become as VA minus VB is equal Vs. If VA minus VB is equal Vs means then we can write that VA is equal Vs plus VB. This is the equation how we wrote here, VA is equal Vs plus VB. And the next one is we have to apply KCL at node A and node B. For suppose if it is the case where I am going to apply Kirchhoff's current law at node A and node B together, then the node equation is called as supernode equation. The supernode equation here with respect to node A, that is only one current which is going from node A to ground. Therefore, that current equation we can write as IA, and here with respect to node B, if you analyze the current, one current is going towards the ground and one current is coming towards node B, that is IS. Therefore, here we will write the equation as like this. So one current is flowing towards the ground and one current is IS which is coming towards VB. Then here we can write that VB divided by R2 plus IS. VB divided by R2 plus IS, because here in this circuit this current is going towards ground and this current is coming towards node. So one current is moving away from the node, one current is moving towards the node. So we can write that VB divided by R2 is equal IS. If VB by R2 is equal IS from node B and similarly from node A, because we are writing that supernode equation. So here one current is flowing towards the ground means that current we can write it as IA, that is away from the node. So I am writing that away from the node currents at one side and towards the current at another side. Therefore IA plus VB by R2 is equal to IS here. Now we are going to simplify these equations to find out that unknown node voltages like VA and VB. So please go through that the following circuit. So let us consider or refer the electrical circuit as shown in below figure and find VA. So if you see this figure, in this figure or in this circuit they given one 8 volts voltage source and one 12 volts voltage source, and there is a one node, there is a one voltage VA across that 500 ohms resistor. And for this circuit, that is one 8 volts voltage source, one 12 volts voltage source and one VA. For this, if you observe very closely, we are labeled the two unknown nodes as A and B are 1 and 2. And there is a one voltage source between these two nodes, that is 8 volts. Whenever the situation happened like this, or whenever the difficulty has like this, that means whenever the two unknown nodes having the voltage like VA and VB, whenever any voltage source lies between two unknown node voltages like VA and VB, like any one value of 8 volts, whatever it may be, then immediately we have to apply the supernode analysis. So apply the supernode analysis at the two unknown nodes like VA and VB and write the equation. So here if you write that equation, we may get VB minus VA, that is VB minus VA is equal 8 volts. From here VB is equal VA plus 8 volts. And while we are writing that supernode equation with the combination of the two unknown nodes like VB and VA, the equation as follows. How the equation as follows here means, here VB, from VB onwards, one current is flowing towards the ground and one current is flowing away from VB, and we will write that equation as this current means we will write that VB by 500, and VB means we can write that VA plus 8, and this current we can write that VB divided by 125, VB divided by 125, we can write it as VA plus 8 or VB minus 12. So we can write that VB minus 12 divided by 125. So 120 VB means we can write here VA plus 8, and one more one, VA minus 12. VA minus 12 divided by 250. Here VA minus 12 divided by 250, and here one more one we can write that VA by 500 is equal 0. As we solve this equation, here we get that VA is equal 4 volts. Next. So therefore by solving this circuit, and here we got that VA is equal 4 volts. Next, one more problem. Use supernode and find the node voltages for the circuit shown in figure. If we look at this circuit, in this circuit we are going to label that unknown nodes as node 1 and node 2, and that too between the two unknown nodes like node 1 and node 2, we are going to refer that reference voltage at node 1 as V1 and reference voltage at node 2 as V2. Between these two nodes there is a unknown voltage source which is called as 36. So we can write that the difference of these two node voltage equations as V1 minus V2 is equal 36. Take it as equation number 1. Next step is applying that supernode technique or supernode analysis with reference to the two unknown nodes and its voltages as V1, V2. So with respect to V1, here the current is moving away from this node and away from this node. Here the current is moving away from this node and away from this node. So first with respect to node 1, here we will write that current equation, that is V1 minus 12 divided by 4 plus V1 divided by 6 plus next V2 divided by 12 plus V2 minus 24 divided by 12 is equal 0. So in this equation we are going to take the V1 and V2 as separate and we'll write the equations. After this, if you solve these two equations like V1 minus V2 is equal 36 and this equation, we may get the two unknown nodes like V1 is equal 24 and V2 is equal minus 12. So now V1 is equal 24 volts and V2 is equal minus 12 volts, and here it is solved to find out that the two unknown node voltages where we are applied that supernode technique to find that the solution for the given circuit. So supernode analysis is useful especially whenever the two unknown nodes are separated with a voltage source. Particular applications only we have to apply the supernode, and while we are analyzing that network, we have to take a common equation with respect to node 1 and node 2 in this network. Then we are going to write that equation is called as supernode equation. Thank you.